Hello, everyone, and welcome back to one of the most exciting tech sessions that I'm really pleased to present to you. I'm here with Todd from OmniSci. Please introduce yourself and OmniSci.
Hey, Robert, good to be with you, and thanks for having me on. I'm Todd Mostak, co-founder and CEO of OmniSci. Some people may know us as formerly MapD. In a past life, we were MapD, same company, same product, just changed our name. Been going at this for some time. OmniSci/MapD started out in my grad school research at Harvard and then MIT, and then spun it off as a company in late 2013. We moved out from the Cambridge, Boston area in Mass to California early on. And now we're about 100 people focusing on accelerating big data analytics with the power of modern hardware, GPU and CPU.
Can you expand a little bit on what modern hardware is? Because it plays a pretty key role in what OmniSci does.
Right. So I think there's been a tectonic shift in terms of hardware architectures, particularly a move towards parallelism. So if you think about it, if you go back into the 90s or early 2000s, people thought, we were just going to speed up the single core of that processors had back then. We're going to speed it up through 3, 4, 5, 6, 10 gigahertz, right? And we would just get our gains as we reduce the transistor size, we would get frequency gains and all was going to be great. Well, we hit a little bit of a speed bump there, no pun intended, where basically they realized that there was a power wall and a heat wall where they couldn't scale the frequency anymore without tremendous, power and heat overloads. And so they started going in parallel, right? You saw CPUs get multiple cores. And then eventually you saw these things called GPUs, which were originally designed to power video games, of course, that took a different approach of having many, many cores instead of one or a few fast cores to basically process graphics in parallel. You could compute the colors of pixels independently for the most part on a screen in parallel. What happened is that people realized that this parallel model, if you could actually harness it, particularly on GPUs, was really powerful for all sorts of heavy-duty compute use cases. Whether that was doing seismic, visualization for oil and gas, whether that was doing things like simulating the Big Bang, or whether that was eventually machine learning, data science, and big data analytics, kind of the space that we're in. And so our kind of insight, which led to the founding of the company, was basically, hey, let's leverage this modern hardware, in this case, GPUs. Let's take all those cores and let's do all the hard work for the user of putting those cores to use to make SQL queries and visual analytics and data science workflows run orders of magnitude faster than they would in traditional technologies, which tended to be CPU bound and even single threaded. So
I love the idea of using technology to gain a competitive advantage. That's sort of the premise of a lot of data science in general. So I suppose it's fair to say that speed is a fairly central value proposition of what OmniSci offers. And just casually speaking, probably most vendors would say that their product is fast enough. What does it mean to be fast? Just exactly how fast is OmniSci?
Right. Yeah. So, I think to your point, if our company had a middle name, speed would be somewhere in it, right? Because, yes, people do say it's fast. Their stuff is fast enough. And I would say that can be true within a certain realm, right? Like, so if you don't expect to get real-time analytics, if you're already doing things with a batch or, kind of pre-baked mindset, like we're going to cube our data, we're going to heavily index it, we're going to run all this stuff, say in Hadoop overnight, and we'll get our report in the morning or maybe next week, then what does 30% faster really get you? It doesn't fundamentally change the game. But if you make it fast enough, if you have enough of a quantitative edge, it makes a huge qualitative difference in what the user can actually do. So, for example, OmniSci, one of our claims to fame is being able to take billions of records, not index it, and then be able to run kind of heavy-duty analytic queries and visualization over that data in milliseconds. And you might say, well, who needs it in milliseconds? Well, that opens the door to a set of new opportunities. So imagine you're a user and you're seeing log data. Imagine you're a telco and you want to see, why are my calls being dropped? Or is there kind of fraudulent calls, robocalls on the network, et cetera. Basically, you can go in and, the human visual perception system is one of the most powerful processing systems on the planet, basically go in and say, oh man, look at that anomaly. I want to drill down onto that. What's that spike in X? Why were calls dropped there? And then you can slice and dice at kind of the speed of curiosity to determine what's the root cause of what's happening. And kind of all our customers do say, this is fundamental new capability for us. We didn't even know this was possible. We used to do this and say, there's a problem on our network. We're going to take hours to figure this out. And now we can do it in real time and be much more agile in response to changing conditions and just the problems that crop up each and every day.
So you're saying that the speed difference is not on the order of 20%, but it can reduce it to orders of magnitude? Is that the difference that GPUs can make in many cases? I know in video games, a good GPU does make a big difference compared to a computer that doesn't have one, but is it the same case with databases?
It is very similar, right? So the thing, like, you would never run a high quality video game on CPU. And even when people run them on CPUs, they're running them on the little integrated GPUs. Same thing for analytics. We feel that by massively accelerating and running, GPU can have over 5,000 cores each. A lot of our customers have, servers with 8 of these GPUs. That's 40,000 cores. And then you have a cluster of 10 of these things sometimes. So that's 400,000 cores. It's effectively a supercomputer. So, that can give you orders of magnitude speed gains. That can take things that take hours down to sub-second. The other thing, though, I'd like to point out is that it's not just the hardware, right? Companies have seen the power of this hardware technology of GPUs and have started to enter the space. But if you don't optimize your software for it, if you don't build the fastest software for the fastest hardware, you're leaving a lot on the table, right? Especially GPUs require a fundamentally new paradigm in thinking about how you're going to process data. You have to think parallel first. And so we've done a lot of work to kind of eke out all the performance of the system. And so that, we're actually kind of achieving in many cases what's called roofline performance, or what's the theoretical max that the hardware can support. A lot of legacy vendors, if they were to try to take their systems and port to GPUs, maybe they would get some speed ups, but they'd probably be leaving many X, maybe they would say be at a 5th or a 10th of the potential because they're not architected to take advantage of that parallelism from the ground up.
You mentioned something about making the data ready at hand and visualizing it, and the human visual perception, that it's one of our great assets. So OmniSci is more than just an OLAP database. It includes a visual component as well. Can you talk a bit about that component?
Right. No, I think it's pretty key for us because early on we realized, and especially as we started to encounter our first users and customers, that one of the key killer apps of having all this speed is accelerating the human in the loop, right? And as much as we talk about the panacea that will be AI, and certainly we're making tremendous progress on that front, most people still need a human, a subject matter expert who knows the domain and knows maybe they're deep in, what's a fraudulent financial transaction or why a call would be dropped. They're a telco network engineer, and they need to be in the loop, and they need to basically not be hindered by the lack of speed of the hardware and software at their disposal to kind of figure out the correlations and anomalies in their data and get to the answers they need. So visual analysis is a really, you think of traditional BI, which is like mostly static reports, and certainly tools like Tableau have made some progress towards making that more interactive, but still fundamentally it's not exploratory, right? Especially at scale when you have billions or tens of billions or hundreds of billions of records. So what our system does is pair the fast database, the very fast SQL, with a very interactive visual analytics front end. And so you can put something like Tableau on top of our backend, and it's much faster, right? But our tool was designed, our front end immerse was designed from the ground up. We know we have a fast backend, and we optimize for it. And so we're not afraid to give the user a sledgehammer to use all that compute on the back end in the service of finding insights faster.
Okay, so you can use Tableau on the front if you want to, so that your existing investments there can still benefit from OmniSci in the back. And then for other new use cases, if they want to, they could either choose Tableau or immerse, depending on what they prefer.
Right. And that's a common pattern, Robert, actually. I think a lot of people have made significant investments in traditional BI tools. And these systems are very mature, and they have large user bases inside our customers. So it's nice that they, it's bog standard SQL, just much faster, so they can accelerate their existing investments. But with immerse, they get something different, which is really geared towards interactive data discovery and exploratory processes. The one thing I didn't mention before is the other very cool thing about GPUs is not only can they crunch things fast, but obviously they were designed to originally render video games. So we can also use that to good effect. Particularly a lot of our customers have big spatiotemporal or geospatial data. Imagine, all your call data records, where people are connecting to cell towers, telematic data coming off of cars, data coming from satellites, any kind of sensors. I mean, think of the world of the IoT world. And what we can do is use, not only query the data quickly on the back end on the GPUs, but without copying it off the GPU or anything, we can render it in situ. So we can take billions of points or lines or polygons and actually render them interactively onto a map. And so if you think about most client server architectures, whether it's a Tableau sitting on top of a server or a traditional GIS tool like ArcGIS, you're going to cap out at 10 or 100,000 rows. You hit a scalability wall. You can't send all that data to the front end. The front end's not using GPUs, so it can't really render it, even if you did get that data. And so what we can do is render it in situ on the back end and make the user feel like they have the billions of points in their browser, but we're actually leveraging the graphics cards in the back end to do that rendering interactively.
So geospatial capabilities is super interesting. I think a lot of databases, especially old relational databases, have geospatial capabilities. And then you typically have separate tools like ArcGIS, where you're very focused on the geospatial aspects of it. But like you said, trying to draw out more than 10,000 elements at the same time will slow it to a crawl, absolutely. And you tend to have this long stack of tools. Is OmniSci something that would sort of consolidate that? Because if you're working with geospatial data, or how do you see yourselves positioning yourselves?
Yeah, for certain key use cases, absolutely. So one of the things when we market ourselves, we talk about converged analytics, right? And converged analytics means fundamentally, traditionally, you've had these different spheres. You've had the analytic BI person either using SQL, maybe Excel, and then BI tools like Tableau. You've had the geo person using GIS tools like Esri. And then you've had like data science, data scientists using probably programmatic workflows in Jupyter, or in your case, Julia or something, right? But they're doing it programmatically. And the idea of converged analytics is that we can bring all those different aspects. People are seeing the elephant in different ways, often working on the same data. And we can converge that understanding with one platform. And so a lot of the work that's shared, whether it's ELT or building basic visualizations or building blocks, can be shared. Now, in the case of geo, one of the things that's interesting is like right now you're kind of stuck between two hard places, particularly if you're not strictly in the domain of traditional GIS. So traditional GIS, like a county trying to survey all the light poles in their, in the admin district or the county, right? Something like Esri is going to work really well. It's not big data. It doesn't require a lot of non-geospatial insight, right? So the old GIS tools do great at deep geo analysis, deeper than we can go, like viewshed analysis, right? So that's great for that domain, but they don't scale and they don't provide traditional analytics capabilities. Similarly, traditional BI tools might excel at general purpose analytics. They're often very weak at geo because it's a different modality of understanding and it requires a lot of compute and such. The BI tools often scale a little better than the GIS tools, but still, like we talked about, they're still fairly static and can't handle billions of records well. So our system can converge the two, right? Where it's a new workflow. It's not traditional GIS. It's, again, you're trying to understand what's happening on your network. It's maybe it's a car maker trying to figure out where their autopilot and why their autopilot's going wrong. Where do people grab the wheel? It's people actually doing retail site analysis, right? Where do they put their store based on location data, based on census demographic data, et cetera. So these are not traditional GIS domains, but it's something that both traditional BI and traditional GIS tools don't serve well, both from a scale and functionality perspective.
Something I've been talking about for the past few days here is the importance of not simply having math chops, but having computer science chops, being able to program and that kind of thing. And what do you say to people that are, really hot on Python and they want to maybe use rapids and they like the idea of OmniSci and the speed and the visualization aspect? How do they sort of marry the tools that they're happy with in Python with what OmniSci can offer? Do they work well together?
No, and that's one of, I think, our key value props, because even though we've built this, nice user-facing front end and immerse, we're still fundamentally a platform. You have full access to the power of SQL. And not only that, for the data science stack, we've done significant work integrating our platform with, particularly on the Python side, the PyData side, right? Where you have inbuilt, you can go from immerse straight, flip between a Jupyter notebook. There's interoperability. From there, we've done integration with something called IBIS. IBIS is a pandas-like API that issues SQL out of the back end. But we have advanced support for that. You can do inline visualizations with Altair in your Jupyter notebook, which is based on Vega. And so data scientists can basically accelerate a lot of do what they're normally doing, but have something that's 100 plus X faster. Not only that, but there's a rich ecosystem emerging around GPU accelerated data science, particularly under the umbrella of the NVIDIA Rapids project, which is open source. And so we've done some work on integrating that as well. So you can take the results right out of the database and then actually push them into inference or training machine learning pipeline, and then actually take the results of that and feed them back into the database, right? So you can do advanced stuff outside in Rapids, or you can even do it inside. We have now support for taking Python user-defined functions, and we actually compile them down into our system. So we have a lot of capabilities that allow the more advanced users, people doing advanced analytics or data science, to get a lot of value from the system alongside more traditional users. And this is what happens with our customers, right? We have somebody who's a very basic kind of BI user alongside somebody who's kind of a top-notch data scientist, all getting value from the system.
I think that's a pretty good value proposition, to not have to ask people to change the tools that they're happy working with, forcing people to write their functions in Lua or some strange language like that. So one thing I'd like to ask you is, what industries do you see OmniSci finding success in? Because there are companies here that, they're on top of data science, and then there are some that say, we don't have enough interesting data. Is OmniSci only working in industries like oil and gas where there's just tons of data? Or do you see a very varied type of clientele? Like where do you see very good applications?
Yeah, it's funny. I think it's been very varied, if you will, in the sense that almost every industry, big data is a major phenomenon. There's a lot of hype around big data, but I think, 10 years later or whatever, it's increasingly a reality, right? So one of our biggest commercial spaces is telco and communications, right? And so you think about all the data coming off the network. So it's call data records, it's the handoffs between cell towers that people need to troubleshoot, it's all the billing records, it's if you're going outside kind of the US or Western markets, a lot of it's prepaid. And so there's a lot of kind of retail analysis of how these things are being sold, how do incentives affect sales. So all of this is big data. A lot of it's very geospatial, and so I think it's uniquely suited for our platform. Likewise, we've seen this in retail, whether it's site analysis or propensity, brand propensity, retail and CPG, right? Oil and gas, as you mentioned, is obviously a ton of data, both at the well level and the seismic level. Even things like insurance are now becoming big data problems, where it's not your traditional actuary that would sit there and work with pen and paper or Excel. That's not happening. People are actually using satellite imagery to gauge the risk level that a roof will leak or something, so they can offer people good insurance rates, risk-adjusted driving profiles, even like natural disasters. Reinsurers in particular need to gauge the risk from a hurricane in an area so that they can adequately value that risk in their estimates. So it's everywhere, right? Everybody has big data, and of course there are problems that are not big data problems, but I think the world, and if you want an edge over your competitors, you have to leverage the data at your disposal.
Let's put things into context here. This is a peeve of mine. A lot of people use sizes of data, and there's very seldom context in it. I spoke to a bank quite recently that was lamenting how much data they had to deal with. So much data, hundreds of millions of rows of data they had. And depending on the context, if you have an Excel file with 100 million rows, I'm sure that's a lot of data. And I'm sure that if you have, a cluster of 200 Cassandra nodes, it's not a lot of data. So it all depends on the context. What advice can you give to decision makers that are really trying to understand the scope of the problem that they have when it comes to data volumes, especially for decision makers that are looking to maybe invest into advanced analytics right now? How should they be thinking around data volumes and the challenge that they face?
I think you make a good point, Robert, that it is all relative, right? And it's relative in the sense of, is the scale or the velocity of the data getting in the way of timely business insights or decisions, right? And some use cases some things have massive data, right? But it doesn't really matter if you make timely decisions. And so maybe those are less good candidates. You could use traditional big data tools for that. On the opposite end of the spectrum, like you said, there are banks with hundreds of millions of rows, but it's like real time. I apologize for my kids outside. Real time risk, or you're doing something where being able to make real time decisions, and that both means up to date with the data coming in, not making tomorrow's decision on today's data or today's decision on yesterday's data, but also in the sense of users being able to get to their insights fast, which also means that they'll dig deeper, right? Like if they have something slow, they're going to do the bare minimum, the very basic roll-ups, and they're only going to get surface deep on what's actually happening with the phenomena that the data is you're trying to reveal from the data. If you can go faster, you can dig deeper, you can ask more questions, you can get deeper insights. So I think it is all in the context of what is the goal, and is the volume and velocity of the data a barrier towards getting the business insights that are needed in a timely fashion.
I think that's a really good point. I'd like to dig just a little bit deeper in it. Very few people in these talks have been willing to speak in terms of absolutes. One person said that the cloud, it's a necessity, that kind of thing. But I like the point you're making now, where you're saying that in terms of the context of your data volume and what investment you're supposed to be making, that the focus should be on how important it is to come to an insight in a timely manner, and what that insight means to you. Do you have any other advice to companies that are looking to take the next step in the analytics journey? Because right now, people have gotten so far that they've done a lot of POCs. They've staffed up and they have data scientists. When it comes to investment, is the important thing having an infrastructure in place, making decisions on a single use case the right way? What success cases that you've come across with customers that have implemented OmniSci, what have been the factors that have led to success in those use cases?
Right. No, this is that's a great question. So, first off, I'll say companies across the board are investing either because they have compelling reasons to, or everybody else is doing it, in their big data or data science capabilities, right? And so one thing I'll say first off is that, rightly so, people first invest in the people, right? And these days, as everybody knows and often makes jokes about, a top-notch data scientist or even a competent data scientist is not a cheap resource, right? So one thing I would say, and I've seen this time and time again, is companies spend a ton of money on hiring top-notch talent, but they don't give them the tools. And that's not just OmniSci, right? That's across the board. But they don't give them tools for those folks to be productive. And if you're going to do that, it's like giving Mario Andretti a Ford Pinto, right? You're kind of where the rubber meets the road. It's just you're not taking full advantage of the resources you're spending. I think also in terms of a analytics and data science practice, one of the things I've seen important is it's very hard to get these things right, completely right, top down, right? So if you're going to hire the best people, you also need them to be agile. So part of it's a culture thing, encouraging them to ask the right questions, to dig deeper, to think beyond the static report. Part of it, again, is the tool question. How do you enable them to say, there's something interesting or weird in that data, right? Like we had a gaming company use our platform, and just because they had a culture of curiosity that promoted curiosity, as soon as they got our tool, all of a sudden people said, well, I've always wondered about that. And all of a sudden they found and pretty big gaming companies, they found 10% lift through different things they could do in their game to get it stickier and et cetera, et cetera. And that improved revenue from that game, or stickiness, I believe, 10%, which I know doesn't sound like a lot, but was huge for them, right? You realize that they're optimizing on the micro percents here. So, and that's because they had a culture of curiosity, and then our platform enabled those data scientists and analysts to use that curiosity to find insights. And it wasn't top down. It was just people saying, hey, I want to explore. I care about this business problem. So
It's very difficult to speak in terms of truisms or absolutes in this market, but for sure, being able to be agile is super important, especially when the technology is changing this quickly. This year has been a very special year. So I'm curious to hear from you in closing, perhaps, is how has this changed the way people are using OmniSci, and perhaps what opportunities are presented now that companies are looking inwards with respect to what OmniSci can offer in this experimentation and agile way of finding your way forward into where you want to take your advanced analytics?
Right. No, I think the case of COVID-19, the pandemic that we're in the middle of, actually makes the case in spades for agility, right? Because if you even think about, we would hear this sometimes. People would say, well, I kind of understand my business problem. It doesn't change that much day to day. And so why do I need a tool that enables me to be agile? Now I think people realize that, hey, well, not only there's always black swans, but we're in the midst of an epic one, and human behavior has changed in a way that probably we haven't seen worldwide since World War II, right? And so, to get on top of that, and it's going to change buying behavior, it's going to change transport behavior, it changes, work behavior. You need to basically, you're going to have to recalibrate all those machine learning models you built. But to do that, you need to first kind of understand what's going on. And so a lot of our companies have been using Skyhook, actually, which is an indoor location provider, has been using our platform to get insights into changing retail and consumer behaviors from their location data using OmniSci. And that's been the case, over and over. We've had insurers readjust their risk profiles as they've changed. Drivers drive, they drive differently, they drive less, they change their commute patterns because of COVID-19. So I think it's a great case in point of why it's important to be agile. And, specifically though on the COVID-19 thing, we've also seen some pretty interesting use cases around contact tracing, both commercially and in the government, the public sector. But we've actually had it's a fleet management company in Australia, use us because they have a big workplace and they do need people in the office for various things. And so they wanted to basically see where people were, and if somebody got sick, they could do contact tracing. And we've been exploring this with other kind of manufacturers as well. On the federal side, contact tracing and hotspot analysis, obviously you have to do it in a way that protects people's privacy, is top of mind for everyone, whether it's at the municipal, state, or province or federal level. So I think there's a rich set of use cases for fast, scalable analytics.
I think one of the neat things about OmniSci is it needs to be experienced a little bit to be believed. If somebody wants to get started and try it out and test it with their data set, what is the smartest way to do that?
Right. So we have a number of ways. We try to make it very easy for people to get started. And we have a lot of faith in our platform. Partly, one thing I haven't mentioned, because it's fast, means that you don't have to index or do all the pre-prep or massaging of your data that you often have to do to get good performance. And so people can often get started, get their data. We had an big oil and gas company that said, 10 minutes, we got our data into the platform, 500 million rows. And another 5 minutes, we built a dashboard and we were off to the races. They had never kind of seen that time to value in any product. They were expecting like a month's implementation time or POC. So there's a few routes to get our product. I invite you to go to our website. The first thing you can do, to get your toes in the water is actually try our interactive demos. They're not gated. So if you just go to our website, go under Learn in the header, and then you'll see interactive demos. And you can basically, I think we have 11 billion record ship demo. We have taxi data. We have an oil and gas demo. And so you can try different, and a real-time Twitter demo, which people love. So you can search for what people are saying about COVID. It's up to date within the last 5 seconds or so. And so you can get a taste of the platform from that. Next, if you're interested in diving deeper, would suggest that you go on our website, you can actually contact us, right? And you can contact us to get a trial. We actually have a self-service trial right on the website. And the core of our platform is open source. So we also invite people who are more keen on just the database thing. It doesn't have all the bells and whistles, but it has most of the core technology to try our open source, and we have builds for that. So there's a number of ways for people to get access to our platform, also on the cloud. So you can spin us up hourly on AWS, Azure, and GCP.
Oh, I think maybe that's important to point out. This does run in the cloud and not just on premise on special hardware.
Right. That was huge for us, right? Because when we started the company, especially using GPUs, it was not everybody had access to these. And now I'd say more than half our deployments are in the cloud. Some people obviously still have to run on-prem. Telco, often our bank may want to run on-prem. But it's easy to get access in the cloud. Within a few minutes, you can be running our software.
That's pretty neat. All right, cool, Todd. I think you've really squeezed in a lot of information in a very short amount of time. I encourage everybody to check this product out. Contact Todd if you want to try something out. And I will be seeing you all at the next session. Thank you very much. Thank you, Todd. See you soon.